Okay, continuing from where we left. So we were discussing about derivatives of functions defined implicitly. Implicit functions का derivatives. Demand was a function of taxes, which was a sales tax, and the price before the taxes. Supply is a function of prices. Now what we had was the equilibrium price P, and this equilibrium price would also be dependent on the tax level. It depends on the T, the tax level as well. So the equilibrium condition should be demand equals to supply. Now if we use total, so suppose this happens, this is true for some T. Okay, if this is true for some T in an interval, then what we have is, okay, suppose this is true for T for some interval. Then using partial derivatives, what we have is f dash T Tp into dt by dt, this would be 1, plus f dash P T by P dP by dt is equals to G dash P dP by dt. This is 1. So now if you simplify this, what we'll get is dP by dt अगर फॉर्म हमें चाहिए तो this becomes G dash P minus F dash P Tp equals to F dash T Tp. So what we have is dP by dt equals F dash T upon G dash P minus F dash P Tp. So this is the final value that we are getting for dP by dt, and we are using implicit differentiation. Okay. Now moving forward, the general equation for the tangent to fxy equals to c. Now हमने देखा, अगर suppose this is a curve and put this is at point P, which is x naught y naught. Then जो हमने देखा, जो स्लोप निकाल रहे थे हम y डैश, दिस वॉज कमिंग आउट टू बी माइनस f1 डैश x नॉट y नॉट अपॉन f2 डैश x नॉट y नॉट. ये हमने पिछली लास्ट वीडियो में देखा. तो एट दिस पॉइंट द स्लोप ऑफ द टेंजेंट इज गिवन बाय दिस थिंग. दिस इज द स्लोप ऑफ द टेंजेंट. एंड हमने पढ़ रखे पहली क्लासेस में चैप्टर 2 में y इक्वल्स टू y नॉट इक्वल्स टू m टाइम्स वेयर m इज स्लोप times x minus x naught. So this gives us y minus y naught equals to minus f1 dash x naught y naught upon f2 dash x naught y naught times x minus x naught. Okay, and further simplifying this, this would be f2 dash x naught y naught into y minus y naught plus f1 dash x naught y naught times x minus x naught. So this becomes equals to 0. I have just simplified this, and the condition is that f2 dash x naught y naught should not be equals to 0, because then the slope won't be डिफाइंड, तो ठीक है वो फिर वर्टिकल सा हो जाएगा. ओके, नाउ द क्वेश्चन इज वी आर डूइंग एग्जाम्पल 16.13 and so they have asked to find the tangent to the curve. 16.13 example, tangent to the curve. The curve is given in example 16.10 minus 2y square plus 10 minus 10y equals to 0. Now you will see f1 dash x naught y naught times x minus x naught plus f2 dash x naught y naught y minus y naught equals to 0. This will give you the slope. Now f1 dash x naught y naught, this is 3x square, and this was we are supposed to find at points 2 comma 1. X naught y naught is 2 1. This is 3x square plus 6xy, plus 2xy times x minus x naught plus x square minus 4y minus 10 times y minus y naught equals to 0. So you can simplify this. X is 2, so this becomes 12 plus 4 x minus 2 plus x square is 4 minus 4 minus 10 times y minus 1 equals to 0. So this is 16x minus 32 minus 10y plus 10 equals to 0. So this becomes 16x minus 22 equals to 10y. So y is coming out to be divided to 5y equals to 8x minus 11, y equals to 1 by 5 8x minus 11. This is what we saw before as well, right? Now the thing is, this vector f1 dash x naught y naught and x naught y naught, which is also denoted by it is the gradient. It is the gradient of f of xy at x naught y naught. And this particular thing, it is writing it as equation B. This can be written as this gradient dot product x minus x naught y minus y naught equals to 0. So which means both of them are orthogonal to each other, that the gradient is orthogonal to the tangent. So this was the tangent, so the gradient would be this f1 dash x naught y naught comma f2 dash x naught y naught. So this is the gradient, the one in green. This is the gradient and this is orthogonal to the tangent, which I'm drawing in red. So this is what we have got because the dot product is coming out to be 0. Okay, now what we have is, if hk is a unit vector, recall what is a unit vector. A unit vector is a vector whose length is 1 and the gradient is not equals to 0, then what we have is, ये हमने पहले भी पढ़ा था डायरेक्शनल डेरिवेटिव, दैट डी इक्वल्स टू, ये मैंने शो भी करा था टाइम, दिस इज द डायरेक्शनल डेरिवेटिव, डायरेक्शनल डेरिवेटिव of the function fxy at x naught y naught in the direction h के. ठीक है, ये हम पहले पढ़ चुके हैं. तो बेसिकली व्हाट डज दिस मीन, अगर x नॉट y नॉट से 1 यूनिट मूवमेंट हो रही है इन द डायरेक्शन ऑफ h एंड h के, देन f x naught y naught changes by this much by the directional derivative. I hope this is clear. मैं फिर से एक बार रिपीट कर देता हूँ. x नॉट y नॉट है, वो ओरिजिनल पॉइंट है, उस पर अगर 1 यूनिट मूवमेंट हो रही है इन द डायरेक्शन ऑफ h एंड k, देन द वैल्यू ऑफ एफ एक्स नॉट वाई नॉट वुड चेंज बाय दिस थिंग. ठीक है, अब ये जो मैं फॉर्मूला लिख रहा हूँ इसका प्रूफ तो नहीं आएगा तुम्हारे कोर्स में, इसलिए वो मैं नहीं करवा रहा. नाउ अब ये मैक्सिमम वैल्यू तब होगी जब ये चीज़ हाईएस्ट होगी. तो जब थीटा इक्वल्स टू 0 है तो व्हाट वी हैव इज cos theta equals to 1, and when theta equals to 0, इसकी डायरेक्शन इस द डायरेक्शन ऑफ द ग्रेडियंट इज द सेम एज द डायरेक्शन ऑफ दिस. ठीक है, तो मैं ये इतना डेप्थ में तो नहीं जाना चाहिए, तो ठीक है, हाँ ये थोड़ा डेप्थ में हो जाएगा, बट ठीक है इतना भी समझ जाओ, फिर हम मूव करते हैं. दोनों की डायरेक्शन सेम वे में होती है बस. तो हमारा पर्पस क्या है, फर्स्टली कुछ प्रॉपर्टीज़ लिखते हैं ग्रेडियंट की. नाउ फर्स्ट प्रॉपर्टी इज, इफ gradient is not equals to 0, then first case this is capital Fxy is orthogonal to the level curve if xy equals to c. And the second property is points in the direction of maximal increase. ऑफ एफ एक्स वाई. तो बेसिकली ये मैक्सिमम तब हो जाता है जब ये वैल्यू 1 लेगी. ठीक है, तो ये और ये दोनों सेम डायरेक्शन में जा रहे हैं, तो ये मैक्सिमम तब होगा जब ये वैल्यू 1 लेगा. अगर लेस देन 1 होगा तो वो वैल्यू अपने आप छोटी होती रहेगी. तो इन द डायरेक्शन ऑफ मैक्सिमल इंक्रीज, तो ग्रेडियंट बताते कि मैक्सिमल इंक्रीज हो सके. ठीक है, नाउ इम्पॉर्टेंट इज दिस अ फॉर्मूला for the second derivative. What we have found was y dash equals to minus f1 dash x comma y f2 dash x comma y. Now let's suppose we write g x as f dash x y 1. and hx as f2 dash xy. So y dash can be written as minus gx upon hx. So if you want to double differentiate it, we'll use quotient rule, which is minus तो बाहर है, माइनस तो बाहर है, g dash x into hx minus h dash x into gx अपॉन hx का होल स्क्वायर. हमें पता है कि y इज अ फंक्शन ऑफ x, तो उसके हिसाब से gx and hx are also function of x, तो they are composite function of x. राइट नाउ, तो अगर कॉम्पोजिट फंक्शन है तो वी आर सपोज टू यूज चेन रूल. नाउ इफ वी आर यूजिंग चेन रूल, जी एक्स इज दिस, जी डैश एक्स वुड बी, ठीक है, आई एम राइटिंग जी एक्स इज एफ वन डैश एक्स वाई, सो जी डैश एक्स वुड बी एफ वन वन xy into derivative of x1 plus f12 xy into derivative into dy by dx. dy by dx is nothing but y dash. Similarly, hx is f2 dash xy, then h dash x would be f21 double dash xy plus f22 double dash double dash xy into 1 with respect to x tha into y dash. Also, if you will substitute these values of gx into this, so I'm not doing the calculations, I'll tell you the final result. It is coming out to be minus f2 dash cube yeah, I don't expect you remembering this, but they might ask a question from this. Or the more general form, what you can do is, you can note this down, that if fxy equals to c, this implies y double dash, which is dx2. This can be written as sorry, f2 dash 11 f12 f21 f22. So I guess instead of this c, it is easier to remember d. ये तो हम सॉल्व कर भी लेंगे. Okay, let's do an example. 16.14. Find y double dash when x y to the power half equals to 2. So I would expect you to solve this. Okay, you are supposed to find f1 dash f2 dash. So this is differentiating the function with respect to x with respect to y. Then f11 then f12, f21. So, and with the help of the Young's theorem, we know that f12 would be equals to f21. So I expect you to solve this on your own and see, or you can directly find y double dash as well, but it's better to try to use this method as well. We can directly also find it, because the product rule would be 1 into y to the power half plus x into half into y to the power minus half into y dash equals to 0. You have y dash, you'll get y dash, double differentiate this, you'll get y double dash. So take a minute to solve this and try to use both these methods, this and the normal general method. I'm giving you 3-4 minutes to solve this and just verify that whether you are getting this as your final answer or not. I'm giving you 3-4 minutes to solve this. Okay, try solving this. In the meanwhile, I'll write some point for. Okay, I hope you have solved this. Now moving forward, now we have already taken the case of 2 variables. Now let's take a case of 3 variables and then n variables in general. अब यहाँ पे एक c is a constant है and variables are x, y and z. तो बेसिकली ये इक्वेशन एक पूरा सरफेस बताएगी एंड 3D डायमेंशन में of all those points such that fxyz equals to c. So this is called graph of the equation. Okay, now suppose z equals to f of xy. So what we have is f of x y z equals to c. This can be written as f of x y f of x y equals to c for all x y in some particular domain A, right? Now if we assume that f and small f are both differentiable, let's define a function. ठीक है, मुझे नहीं पता ये प्रूफ आएंगे या नहीं, बट ठीक है, वी विल स्टिल डू दिस. y fxy equals to c. Since it is equals to c, so what we have is gxy equals to c. So g dash x and g dash y are both equal to each other and are equal to 0, because this is a constant. राइट साइड का डेरिवेटिव लोगे तो वो वैसे 0 हो जाएगा. सो व्हाट वी हैव इज g dash x equals to g dash y equals to 0. नाउ अगर हम g dash x निकालें यूजिंग चेन रूल, g dash x is f dash x into the function times derivative of x 1 plus y is not dependent on x, so 0, plus f dash z, so this was z only, but z is still a function of x, so z dash x equals to 0. G dash y f dash y into 1 plus f dash z into z dash y equals to 0. Now solving this, the first equation is f dash x plus f z, z dash x equals to 0. So z dash x is coming out to be minus f dash x upon fz dash. Similarly, from the second equation, what we'll get is zy dash equals to minus fy dash upon fz dash, and it is being assumed that fz dash is not equals to 0. Okay, now let's do an example related to this. Example 16.27. The equation is x minus 2y minus 3z plus z square equals to minus 2. So we are supposed to find it at x, y, z equals to 0, 0, 2. And it is said that z is twice differentiable function of x and y. So z dash, this exists. So they are asking us to compute z dash x, z dash y, z, zy double dash, z, xy double dash, and find the numerical values of all these partial derivatives at 0, 0. इन सब की वैल्यू फाइंड करनी है 0, 0. ये एक्स वाई, ठीक है. नाउ let this be the equation f x y z equals to x minus 2y minus 3z plus z square equals to minus 2. तो हमारा c तो हो गया minus 2, ठीक है. Now moving forward, what we have is f x dash हो जाएगा 1, एफ वाई डैश हो जाएगा minus 2 एंड एफ जेड डैश हो जाएगा -3 प्लस 2z. ओके, तो जो हमने फॉर्मूला ऊपर लिखा था वो तब नहीं ये यूज़ कर सकते व्हेन एफ जेड डैश इक्वल्स टू 0. तो अगर ये 0 नहीं होना चाहिए, मतलब -3 प्लस 2z शुड नॉट बी इक्वल्स टू 0, विच मीन्स 3 शुड नॉट बी इक्वल्स टू 2z. So which means z should not be equals to 3/2. Then we can use the above formula. So z dash x, इसकी क्या वैल्यू आ रही थी, माइनस एफ एक्स डैश अपॉन एफ जेड डैश. this is coming out to be minus 1 upon 2z minus 3. z dash y भी निकाल लोगे, minus fy dash upon fz dash. So this is coming out to be minus of minus 2, 2 upon 2z minus 3. अब अगर x0 y0 और z2 है तो दिस z डैश x क्या आ जाएगा, z अगर 2 है तो -1 अपॉन 4 माइनस 3 3 1, सो हाँ -1 आ गया, एंड दिस वुड बी 2 अपॉन 1 विच इज़ 2. ओके, नाउ z डबल डैश x. तो अब क्या करना है, हमें zx को डिफ्रेंशिएट करना है विद रिस्पेक्ट टू x. तो दिस इज नथिंग बट del by del x into z dash x was minus 1 by 2z minus 3. So this can be written as, and this is basic differentiation to the power minus 1, and this is 2z minus 3 to the power minus 2 into 2z dash x, and z dash x की वैल्यू सब्स्टिट्यूट कर दो दिस थिंग. सो दिस इज कमिंग आउट टू बी 2 टाइम्स minus 1 by 2z minus 3, 2z minus 3 की पावर minus 2. सो ये तो -2 टाइम्स 2z minus 3 की पावर minus 3. दिस इज z डबल डैश x. सिमिलरली यू कैन फाइंड z डबल डैश एक्स वाई. ये कैसे होगा, पहले विद रिस्पेक्ट टू x करा था, अब विद रिस्पेक्ट टू y करना है. z डैश x, दिस इज डेल बाय z डैश x was same thing only, -1 by 2z minus 3. Now if we'll solve it, we'll get if we solve it, we'll get the same thing as del y times -1 times 2z minus 3 की power -1 derivative of this. Okay, on simplifying this, we have z minus 3 to the power -2, and then 2 as well, minus sign would cancel out, and z y dash. So this is nothing but z y dash was 2 upon 2z minus 3 2 upon -3. Okay, so what we have is 4 upon 2z minus 3 to the power -3. Similarly, we can find for z y y double dash, which is del by dy into z dash y, which is d by dy into z dash y was -1 upon 2z minus 3. I hope you can solve this. So I'm giving you 2 minutes to solve this. Okay, the same logic that we'll use. So what we'll get is what is z dash y coming out to be 2 upon 2z minus 3. Okay, the z dash y is 2z upon z dash y is 2 upon 2z minus 3. So this can be written as minus 2 times 2z minus 3 to the power minus 2 into 2 to the power z dash y, and z dash y was itself, so this would minus 2, 2z minus 3 to the power minus 2, 2 times z dash y is this term, so this would be 2 upon 2z minus 3. So this becomes minus 8 2z minus 3 to the power 3. Now अब उन्होंने बोला था कि we are supposed to find at 0 0 z dash x all these things. No, not the first two things, the rest three things we were supposed to find. Okay, at 0 0 z double dash x, okay, 0 0 2, because z is 2, so at x equals to 0, y equals to 0 and z equals to 2. Z x x double dash, this is equal to minus 2 times 2z minus 3 minus 3. So z is 2, so this would become minus 2 times 4 minus 1 1. So this is minus 2. Z x y double dash and z y y double dash. Z y y तो यही वैल्यू थी. So it is minus 8 upon 2z minus 3 to the power 3, which is 1, so minus 8. Z x y, z x, ये बेस तो हमेशा 1 ही रहेगा क्योंकि z 2 है, तो this is coming out to be 4. Okay, so we have solved this. Now moving to the general case. Now what is, अब हमने क्या किया था 3 वेरिएबल्स का, बट लेट्स सपोज z is defined implicitly. पहले implicitly as a differentiable function of 3 variables था, but as a differentiable function of the n variables, and let the variables be x1 x2 till xn. Then it would be defined by the equation f x1 x2 till xn equals to c, where c is a constant. So we can come to the general conclusion that del z by del xi, this would be equals to minus del f by del xi upon del f by del z. So, and this is for I equals to 1 2 till n. So this is, we are generalizing it to the case where there are n variables. So when I equals to 1, what we have is del z by del x1 equals to minus f dash 1 upon f dash z. And with this we are done with implicit functions, and we'll move to the other topic in the next video.